Good afternoon, everybody. Welcome to this CIEEM webinar on mapping river habitats from the air. This webinar will be presented by David Campbell from APEM. But before I hand over to David, I'd just like to mention that we will be doing a Q&A session at the end of the webinar. So please do type in your questions into the Q&A box and we will look to answer those at the end. Also, before I hand over, we're just going to launch a short poll. So I'd appreciate if you could make your choices or choice. So the question is, have you used aerial survey data before to help map habitats? And I'll just give you a few seconds to make your choice. Okay. Perfect. I'll end the poll there, and David, I'll hand over to you and share the results.
Hi, thanks very much. So 45% yes. Oh, that's higher than I thought. Actually, that's interesting. Most people that I speak to in my career, it's actually the first time that they've used aerial survey or just considered using it. So that's quite high. So that's quite encouraging. Okay. We have. I'm just make sure I've got full screen there. Okay. So thanks very much. So I'm going to talk about mapping river habitats from the air. So this is how it's possible to go about trying to map primarily fish habitat, but not exclusively from aerial imaging. I'll talk about uses of satellite, uses of drone, uses of fixed wing aerial survey to capture the data, the way that that's processed and can be used to help map those various habitats. I also kind of talk about the traditional ways of mapping habitat and kind of what the pros and cons and the comparison between the two. Then I'll go on to provide a bit of a demo of some imagery and a kind of a live demo of some of the GIS of habitats mapped, as well as talk about some of the case studies where it's been used before. And I hope that's really interesting for everyone to hear. I'll leave plenty of time for questions at the end, so please store up any questions and we can go through those at the end. Just a quick introduction to me. So my name's David Campbell. I'm a Divisional Director for Remote Sensing at APEM. We're an environmental consultancy. There's my contact details if anyone needs to drop me an email. And I've been in the industry of remote sensing for about 12 years. So, and it actually started going down the road of remote sensing for river habitat mapping. So there was a few projects that I was involved with that were looking at mapping out salmonid habitats, and the question was posed of, could you map these from aerial imaging? So it really started from there with, in collaboration with the Eden Rivers Trust, and then things have gone on from there. But my interest in aerial surveys really started with river habitat mapping, and is still very much there. So I will welcome the opportunity to explain it all to you. So, traditional methods of mapping fish habitat. So, for various projects that we get involved with, that people on the call might be involved with, there's a requirement to map habitats within rivers. And the traditional way of doing that is to do a bankside walkover with a paper map. There's usually a large-scale ordnance survey map with the river outline, and the surveyor usually has a GPS with them to help locate where they are. And they would walk along the riverbank mapping habitats as they go. So it would be a visual interpretation of what those habitats are, and the different groupings. It might be spawning habitat for salmon, it might be fry and par habitat, it might be adult passageway habitat for fish. Obviously they can make notes of bankside erosion, etc. as they go, and that would all be mapped onto the paper maps, and then back in the office digitized. Those polygons that are drawn on the river lines will be digitized in a GIS, and then that can be collated in terms of calculating maximum total area of juvenile habitat, for example. So that's a traditional way of doing it, and the different way of doing it that I get involved in is mapping it from the air, so based on aerial imaging. So with remote sensing in general, there's a choice of platforms, and those can be from satellite to airborne, which is aerial photography, as I term it, UAV and drone. And when thinking about what you would use, and there's different purposes for all of those for different projects, is what resolution you can get from the imagery, what spectral band you can get, is it just colour imaging you need, or do you need thermal imaging, or is it near infrared, for example? I'll explain about what those different spectral bands are. Is there a requirement for repeatability in there? And obviously cost is a consideration as well, and whether you go for the satellite, the airborne, or a drone. So with satellite, generally you get low-ish resolution, and things are improving all the time. You can probably get up to 30 centimeters per pixel resolution now with satellite. That's at kind of the expensive end. The cheaper data tends to be around 1-2 meters, and the free data is around sort of 10-meter resolution in terms of color imaging resolution that you can get. So it's used a lot for land use assessment, and in terms of rivers, it's probably good enough for wetted widths at that very higher end when you can get the 30 centimeter data, but it's very limited in terms of habitat mapping within the channel. Airborne, this is where the primary focus of the presentation is going to talk about. That's very suitable for habitat mapping, and the reasons is because you can go when you want. The satellite goes overhead when it goes overhead, and if it coincides with the conditions that you want in a river, then fantastic. If it doesn't, then you don't get the data that you need. With an aerial survey, you can commission that to go at a certain flow level or with certain overhead conditions, and target those conditions that you want. It's very high resolution, so it's up to 2 centimeter per pixel resolution, so you're getting a very detailed data set, and you can do your detailed habitat mapping from there. And then drones, there's either fixed wing or rotary, and they're kind of fantastic in terms of the resolution that you can achieve from them, and they're really good for small sites. So if you had a couple of kilometer long section of river that you wanted to get some imagery of, then they'd be fantastic for that. They have kind of a limited range in terms of how far you can go before it starts becoming less efficient to survey that way, simply because there's kind of rules of the operator being within a certain distance of how far the drone is away from them. So you can only do so much without having to kind of move along the river. So as a general rule of thumb, sub kind of 3-4 kilometer, you might use a drone. If it's kind of beyond longer than that, a longer section of river, then it might be one to go for with aerial imaging. And then the data types, colour and near infrared imagery. So they're the kind of the primary data types that we work with. So colour photography, and then a little bit beyond the electromagnetic spectrum from that is near infrared. So that's the one on the right there that kind of looks quite red. So that's got a very strong response in the red channel when you get vegetation there. So looking at riparian vegetation, looking at depth actually, which I'll come on to as well, is useful because it's red light's attenuated in a predictable way with depth in water. Thermal data, so that's useful for lots of different surveys. In terms of river surveys, you know, thermal data can contribute to the habitat within the river, and there's an example of that I'll show you later on. So thermal data might be required as part of the habitat makeup survey, and that can be captured from remote sensing as well. And then the third type is topographic, either LiDAR or FODAR. So that's FODAR's photogrammetrically derived topographical data. That was a mouthful. But essentially elevation data from imagery, or you can get elevation from LiDAR. And I'm not going to go into the differences between the two too much on this presentation because it's kind of beyond the scope of it. But needless to say, you can get topographic data through aerial survey, which is going to be useful for things like bank heights, for looking at drops across weirs in terms of fish migration. And so if we wanted to go and survey an area with aerial imaging, then we would select our site. We would plan a survey overlap, which would be a series of straight lines. So the aircraft flies over your planned area in straight lines. We don't try and follow the course of the river. It's done in a series of straight lines with overlapping imagery, and those imagery overlap in the forward direction, the same direction as the aircraft's flying. But we also come back and do parallel flight lines next to the first one, so you get lateral overlap as well. And typically that's the kind of that overlap that you can see there, 70% forward, 50% lateral overlap. That's typically what we go for a survey setup, and that allows us to tile the imagery together in an orthomosaic, and also produce that elevation data that we need for the topographical data. In terms of survey spec, of resolution, for habitats, we often go at 3 centimetre resolution. It can go a bit higher than that from airborne data. It can go to 2 centimetres, or for some of the kind of the lower detailed requirements when it's just wetted widths, that's the main focus, then you could go a lower resolution than that. That could be 10 centimetres, for example. But the point is, you would go and you would plan your survey. That would go up in the aircraft, collect the data, and then we would come back and start processing that data with the software. So that slide looks a bit strange actually. I've uploaded just for people's information. You probably see that it's reading my voice as a caption, so I had to upload the presentation to a different bit of software, and it's obviously done something slightly strange with it. So hopefully that won't happen throughout it, but that's the reason for the pink outline. But anyway, there's software developed now specifically for looking at fish habitats or habitats within the river, and that's derived from aerial imaging. So we might be in the types of things that we're interested in deriving to get that habitat data are things like wetted area, which areas are dry, which areas are vegetated, what the grain size, a grain size map of the riverbed, either in the exposed sections or the submerged sections, and what the depth is. And if we've got those things, then we've got a pretty good way of generating some of the habitat data that we want. So the software that's been developed allows us to do that. So for getting analysis of grain size, we can use image roughness as a kind of a proxy for grain size data, and we calibrate that. We have some reference calibration sites that we can say, well, we know that that part of the river has a median grain size diameter of this, etc., etc., as to calibrate the data that we see, and then we have the software process that and produce a grain size map, and that's what you can see with that red shaded area there. So the different colours represent different median grain sizes across the scene. And we can do the same with depth. So in this case, the attenuation of the red channel, red light, attenuates in a predictable way, and the return that we get from the red light is has a relationship with depth. And again, we can use calibration reference data that's collected at the time of the survey to apply to this and generate a depth map from the image. Now, this is for the submerged section. Anything exposed in terms of bank heights or weir heights or the topography, that's generated through a different process. That's generated through photogrammetry, the kind of the overlapping imagery, stereo imaging that the software can use to generate an elevation profile. This is specifically for the submerged section of the rivers. And the accuracy around that, in terms of the depth, is around kind of 15 centimeters depth, which might not be good enough if you're doing detailed cross sections, but certainly when you're looking at habitats and fish habitats, then that's in the zone of what's going to be useful for looking at those different classifications of fish habitat. So this is what the software looks like when it's been generated. We've got those series of images, and we're generating those grain size maps and those depth maps for each of those. I won't go into the interface in too much detail, but we pick one of those images and we can see the cross-sectional profile of that from the elevation data, and we can select to see what the D50 is, the average grain size, for example, from that. And the outputs, once we've got that, we then can use that information to start classifying into useful habitats. So from a fish habitat perspective, we would input what from the literature is described as different classifications of fish habitats. So in terms of juvenile habitat, those juvenile salmonid fish would require a certain grain size that they use as their habitat, and also certain depth. Same with spawning ground, same with adult habitat, for example. And that comes from the literature, that comes from the information, gathered over the years from ground-based surveys. And that's kind of what the output would look like. You process that, and it classifies the river into different habitats, so mixed juvenile, spawning gravels, passageway, and areas that are perhaps inaccessible for fish as well. And once you've got those statistics, everything's geolocated, so you'd be able to generate total areas of juvenile habitat, for example, and that could start to be used as information to start looking at the kind of the carrying capacity of a river. The different life stages, and if you've got the information on survival rates of, juvenile habitat and how many adult fish you are likely to get from the river from that available spawning habitat or juvenile habitat within the river. This is just an example of some of the cross sections that you can derive from the mapping. Once you've got that bathymetric map, So you can, draw a cross section anywhere you want and get that that data out, interrogate the data a bit further. And then outside of the channel, we generate a topographic map if required. So that's an example of kind of what a shaded relief map that would be generated from stereo imaging that would look like, fairly zoomed out there. But if we zoomed in, we could start looking at the data in 3D, and I'll show you a 3D model at the end of this. But that might be useful for measuring drops across weirs, for example, and that would be useful for looking at passageway of fish. Are they going to be able to get over that barrier, or is it a barrier to migration, for example? Temperature. So thermal surveys are often done, or sometimes done from the air when there's specific reasons for it. So this was an interesting case study where there was a draw that there was compensation flow that was coming from a reservoir, and it was drawn off from quite low down in the reservoir. So it was cold water that was being discharged into the river. And even in summer, the height of summer, the temperature of the river that was coming out of the reservoir was kind of as low as 4 degrees. And that was potentially affecting habitat of fish. So in this case, it was the interesting fish was shad, who require certain temperatures. There was an investigation required of, well, how far does the temperature effect of the compensation flow extend downstream? And going hand in hand with that, where is the suitable habitat for shad within the river? And is there a crossover period? Is there a crossover zone, i.e. where the physical habitat for shad is there, but the temperature habitat isn't there? So that's where it was really useful to combine the two methods of getting the physical habitat from the aerial imagery, but the temperature habitat from the thermal imagery. So we flew at the river on a summer's day with the compensation flowing in the standard configuration. We started mapping temperatures downstream, and this is a good example of a confluence of the river. So on the right of the channel, that was coming from I suppose a kind of a natural temperature, what it would be without the influence of the compensation, and that was flowing into the main river that was coming from the reservoir. So you can kind of see, 15, and obviously the further we go downstream, the warmer it gets as you get the influence of these tributaries coming in. And so it was 15 degrees upstream of the reservoir. There was 19.6 degrees coming in at the tributary, and then that was obviously mixing in, but below that was kind of 16 degrees. So we were able to kind of map the temperature at each of those confluence points and map the range of influence of the temperature of the reservoir, and then have a look at the physical habitat and see where the crossover was. And that was, this was done for a water company, and that was hugely useful for those. So an example of bringing in other data that's not just color imaging, thermal imaging as well. Often another kind of advantage that you don't necessarily get from the ground-based fish habitat walkover is that you can expand the search area and go wider along the river and start to look at diffuse pollution, for example, and sediment input reasons to and where that's coming from within the catchment. So you can do that to a certain extent from the ground-based walkover. You can see what the surveyor can see from the vantage point of the riverbanks. With an aerial survey, you can obviously go much wider than that, and capture information that's beyond the immediate vicinity of the river. And then invasive species mapping as well. So this requires certain conditions, so they only become apparent at certain times of the year. But if you do go at the right times of the year, then things like mapping pennywort is quite visual and can be captured from aerial imaging. Japanese knotweed there, and Himalayan balsam's also very visible at certain times of the year when it's in flower from the air as well. So that's kind of the main body of the presentation, of the PowerPoint presentation, and I just kind of wanted to show a few examples out of the presentation, a 3D live demo and some imagery, and then an online GIS that we create as well. So I'm going to lose the captions here, and I'll come back to this so we get the captions again. But it's all very visual, so anyone who does need the captions, hopefully they can still follow, even though they're not going to get the audio. So just bear with me a second. So I'm just going to stop sharing and then reshare in a second. Okay, so hopefully people can see that. So this is an example of a three-dimensional aerial model. So this is hosted online, and this was an interesting survey and kind of points to why sometimes it's useful to use aerial survey rather than ground survey. So, so the fish habitats along this section of a salmonid river could be captured along the riverbanks. There was reasons why it was difficult to get surveyors on the ground with this, and I won't go into the reasons, but it was kind of a costly and a difficult political situation to get surveyors on the ground. So surveying from the air was an option to capture all sorts of different information about this, not just on fish habitats but on other things. So I'll just show you this as kind of an example, and it's just quite visual in terms of the detail that you can achieve as well. So this is a 2.5 centimeter image. This was all captured at 2.5 centimeters. So that's and it's been processed into 3 dimensions as well. So I can navigate around here and look at heights of features out of bank as well as all the kind of the features in bank as well. So obviously useful for mapping habitats, but also useful for looking at other features. For example, pollution inflows. This was an area that the water company didn't know about, the local fisheries team didn't know about. There was obviously an input coming in there. It was useful from habitats perspective to look at features like this. So this was this little tributary here. This was kind of a juvenile salmon spawning area, and these were cattle fields all around it, and there was a cattle crossing point there. As you can see, that's in a state of disrepair, and so the cattle weren't crossing there, they were crossing down here, and obviously causing bank erosion around there and degradation of habitat. So that's, that might have been picked up on the ground, but having that kind of context of seeing everything together and how things fit together is something that's quite visual and kind of an advantage of the aerial survey approach as well. And I should say, so that the examples that I kind of showed you before with the software about mapping habitats, is a kind of a semi-automated way of processing the data. The other way of doing it is just to digitize straight on the aerial imagery. If you've got the depth information, a fish biologist could go along and start digitizing different habitat types in the same way that they would do out in the field. And depending on which, what the application is, sometimes it's done in either way. So that's kind of an idea of a kind of an online 3D data set. I wanted to show you this image as well, because I thought this was quite interesting. This was actually a survey that was done in Idaho in the States, and this was done to map salmon reds. So it was done during kind of the salmon run season, and hopefully you can see that these lighter areas here are salmon reds, and they were pretty visible within the imagery, and they could go and obviously be, everything's geolocated, everything's in the GIS, and it can be mapped as we go down the river. So that's quite a visually striking image that I just thought I'd show you. And then the other demo I wanted to show everyone was what an online kind of GIS mapped habitat looks like. So again, this is data that hosted online. There's the imagery at, I think this one was at 3 centimeter imagery, and there's the habitats that are mapped over it. So in this was an example of one where they were digitized on top of the imagery based on the depth information and the fish biologist's interpretation of what those habitats were. So, for example, here they've mapped that this was bedrock habitat. So essentially, as hopefully you can see from the imagery, there's no gravel or anything at the bottom. That's just straight to bedrock. So from a fish habitat point of view, passageway but not particularly usable. And then further down here, where we're getting the gravels and the different flow types, that's when we're getting the different kind of juvenile par and mixed juvenile habitats and fry habitat. Obviously, you can map the exposed sections and carry on in that fashion. You know, kind of down a whole river reach, as you can see there. So, and as I say, this can then, you know, be hosted online for fisheries teams, for whoever else is interested to see. So that's the 3D demo. Let me come back to this. Sorry. Okay, the caption's back on. Yes. Okay. So that was a presentation. That was, hopefully you enjoyed the demonstration. And at that point, I think it's probably time for Q&A. So let's have a look. Hopefully people have been posting their questions. So what software do you use for generating the depth maps? So this was a piece of information called the Fluvial Information System. It was developed by Durham University and APEM quite a few years ago. It was kind of a result of a knowledge transfer partnership where a research student worked on the data for a couple of years and developed the software. So it's kind of a bespoke piece of software for the specifically for mapping habitats. In terms of cost, for the next one, one disappeared then. Did it go?
Sorry, David, that was me. I moved it to answered so that everybody can read the question.
Oh, I see. Okay. Okay.
Sorry, I'll slow down a bit.
No, that's okay. That's fine. So, how much does it cost for an aerial photograph of a river? So, there's a lot of. It depends on kind of location, the length. Obviously, there's economies of scale for doing this. In general, to get it flown and processed and the habitats produced, it's something like about £200 to £300 a kilometre, something like that. So it really does vary, but hopefully that gives a bit of an idea. And then another one from Mark: what's the cost per kilometre of producing the habitat maps, all expenses included? Okay, so similar question there. From Anne: presumably such techniques can be used to monitor habitat changes following river restoration. Hopefully it's not all about the fish. Yes, they can. And that example that I showed before with the online GIS, that was very much done for that purpose. So there was some work going on to help restore habitat, and actually there was various techniques tried, like putting gravel in and trying to reduce the amount of bedrock habitat there, and due to the flow regimes that were being artificially imposed on the river by hydroelectric schemes. So it was surveyed once before, and the habitats mapped, and then once kind of after it was after the work had been done, and we could compare those habitat statistics and see what had changed. And for that particular one, it was really interesting to see that there was more fish habitat post the restoration work than before. Is there a chance of getting the presentation to zoom in the maps? Is there a chance to get the presentation to zoom in on the maps? Yeah, I'm happy to share the presentation afterwards. I suppose I could. I think this is being recorded, but I'm happy to send that on to and have that distributed. Yeah, I'll follow up with that after the presentation. What software is used for the 3D modelling? So there's various types of photogrammetric software out there. There's a whole array of them. We use a specific selection of them. At APEM, others will use different ones. There's essentially what they're doing is they're taking information from the stereo overlap from the images and producing three-dimensional data. And there's various software packages to help do that. And obviously, there's a certain amount of research that goes into what the best ones are. So we've got our ones that we use. There's a whole package of them out there. What options are available for wooded streams? Well, that is a really good point. Thank you for that. Because essentially, this is and I should have mentioned it earlier on in the presentation, is that where you've got obstructions overhead, that's where it's not really suitable for aerial survey. So there's probably not many rivers where you get complete open cover. There isn't any trees along the bank, and there's a few. And if there's a few trees, then generally, if you get in kind of 95, 90+% coverage from the aerial imagery, then you could probably accept the 5% where you don't get data because of tree cover, because of the wealth of information that you're generating over the whole survey versus perhaps a ground survey. But if you are in a section that's completely wooded, you've got a heavily tree-lined river, then it's the ground techniques that we would recommend for that. what software do you use to create the topography maps and 3D images? Okay, similar question before. For any free software, maybe. I don't know. I'm not. I've not used any free software, but there might be free software out there. How accurate the depth measurements? So that's about 15 centimeters, something like that. If you've got good conditions about, and then the follow-up to that one was about turbidity. So if you've got a highly turbid river, then it's only as good as the data that you can see the bottom of the bed. So conditions are really important, what survey conditions you go out in. So you wouldn't want to go in spate, you'd want to go where you've got those clear conditions. And generally in rivers, you know, you'd be seeing that if you go in the right conditions, you'd be seeing, you know, I don't know, 1 meter plus of depth to the bed, and anything beyond that would be kind of, from a fish habitat perspective, would be adult habitat anyway. If it was a particularly, you know, PT stream or something like that, and you really couldn't see the depth, then, you know, yeah, that's a limitation of the system of that survey type. That, you know, you might not be able to do depth on that. You'd probably be able to do flow types, etc., but perhaps not flow types. On the next one, how does peat, sediment in the water affect the results? Okay, so yeah, same question. Can you give us some idea of costs? I've done that one. Or the impact of trees? Yeah, I've done that one. How can we access airborne data? So there are sites out there. I know there's one that I've used in the past called EMAP site that has kind of stock imagery available for anyone. It's usually not that high resolution. It's kind of usually kind of 20, 30 centimeter resolution, perhaps a little bit higher in places. That's the kind of the available online data that's kind of already been captured and resold. What I've been kind of talking about here is kind of bespoke surveys for this type of work. There's quite specific conditions that you need for habitat mapping. Certainly when you're looking in channel, not necessarily out of channel, you've probably got a bit more latitude, but certainly in channel work, you need to be going when the kind of the river's fairly low, where you've got good overhead conditions in terms of sunlight, and, you know, let's have considerations for certain type of year, you know, in terms of how much vegetation's in the river, for example. So and most importantly, the resolution there, you know, at 3 centimeters or better. So it's very unlikely that you're going to get that through any portal that's going to be that sort of level of data and done at the right time. So it is probably a you know, a commission for those sorts of surveys. So does turbidity affect depth and substrate size? What the limits of turbidity will work? Well, yeah, it's essentially what the kind of Secchi depth is the limits of it. When can you see, if you were stood over a river and you're looking down, can you see the bed? And it'll work to that degree, essentially. How useful are multispectral sensors, and how many bands do you use? So generally for habitats, it's colour and then near infrared. So earlier on in the presentation, I showed you that near infrared image, and that's useful for looking at vegetation changes, and that's particularly useful for when you're kind of mapping land use and riparian habitat. For the in-channel stuff, it's generally the colour imaging that's the most useful, and then thermal for specific investigations, like when you're looking at temperature effects down the river. They're generally the ones that are used for habitat work. Can use hyperspectral sensors as well, so getting very detailed information across the color spectrum, for example, but getting very detailed information on specific wave bands. probably useful for mapping certain types of vegetation, for example. GDPR, are there GDPR issues with flying over homes and gardens? No, there isn't. We have, or a aerial survey company would gain permission from the Civil Aviation Authority to go and fly that and fly over the survey area. So there's no kind of legal restrictions as long as you're doing that in accordance with airspace and you are dealing with the data responsibly. Then there's no kind of legal issues with capturing the imagery. Obviously, if you're holding information about people's personal data and you do something with that, then there might be, but certainly from this aspect of mapping habitats, no, then there isn't. And then if I already have a drone image of restoration sites, is there a program tool you recommend that I can drop them into to analyze? The software that we've used to specifically map those grain size and habitat types is that fluvial information system. So it's not, as I say, it's kind of it was a proprietary piece of software that was developed. So it's available for kind of us to at APEM to process. It's not available for us to give to you to process. But if you wanted to get in touch with me and say, could we have a look at that in terms of processing it for the grain size and depth, then certainly be happy to do that. One from Lucy: how does it calculate grain size? So it uses entropy or image texture as kind of the input data to the software. So the software can see where you've got different grades of image roughness, and then we need to, and that'll give it a figure. That'll give it an image texture score from 1 to 10, for example. And then we need to feed that calibration data into it. So we would go out and it's the equivalent of throwing a quadrat over an area of bank, measuring all the grain size within that 1 kilometre quadrat, and saying, okay, right, the D50, the median grain size for that is 40 millimetres, for example, and that's a calibration point. We actually do it we don't go out physically to the river because we don't need to, because of the resolution from the imagery. We can do that and measure directly onto the grain size from the aerial imagery. So we do that at several points, and then we've got calibration points that we can feed into the system and turn that raw entropy or texture score into a median grain size. Once we've got that calibration data, we then run that across the image, and then it produces that grain size map. One for Ruth: do you know how big the file sizes might be for drone / visual only surveys per kilometre? So, God, that's a difficult one off the fly to know in terms of gigabytes per kilometre. I guess I would say we're probably talking for a kilometre of high resolution data, you might be talking about a couple of gigabytes, I would have thought. The way that the images can be compressed and output, once you've kind of done your processing and output it, you can compress it in a really kind of efficient way. So no, probably not gigabytes, actually. I don't know, half a gigabyte to a gigabyte maybe per kilometre, but that's a bit of a guess without looking into it. So is the fluvial information system available for third-party use? No, it isn't. It's a proprietary piece of software that was developed specifically for that. There is obviously, the kind of the digitizing methods. So that was that the other way of digitizing habitats based on essentially a visual interpretation of what those habitats are. And if you've got the imagery to go into that, then that's, you know, a really, really viable way of doing it as well. From, you know, getting a fish biologist or a habitat expert to go and look at those images and digitize on top of those images, so that you would need a GIS for that once you've got the imagery there. But in terms of the FIS specifically, no. What future developments do you foresee or know of with mapping river habitats from the air? So one of the things that's being worked on at the moment is, instead of using the attenuation of the red channel to look at river depth, is that we use the photogrammetry to derive the depth within the channel. So that's something that there's been a bit of progress on, and that removes the need to have the calibration data in the same way, because in the same as when you're looking at exposed land and topography, the software can generate that topographical data directly. So if you can do that underwater, then you don't need, I suppose you don't need the FIS, the fluvial information system, for that bit of it. So that's something that's being developed. And also for bathymetry side of things, you know, kind of direct measurement from bathymetric LiDAR. So that technology is out there at the moment. It's just very expensive. There's not many bathymetric LiDAR units, certainly in the UK. There's only kind of 2 or 3, I believe, that are operational worldwide. But they kind of, in the same way that LiDAR, I don't know if people are aware of LiDAR, but it's a kind of an active laser that pings down and gets a direct measurement of elevation below the aircraft, and it generates something called a point cloud, so a series of points. And up till recently, it's just been absorbed by water, so you don't get any information below the water surface. But now the technology is there, so you can get information below the water as well. So that's a definite improvement, and it's going to be really applicable. The barrier to that at the moment is just the expense of the kit, because it's fairly new. That's not really available for smaller projects, and it's generally used for kind of big offshore projects where you're kind of mapping whole country coastlines, for example. However, there are projects where that are piggybacking on to the availability of that, you know, kind of if they're doing a big survey somewhere else and then piggybacking onto river survey. So I definitely wouldn't rule it out. And if anyone is interested in bathymetric LiDAR surveys, then, you know, please do get in touch. So from Gemma, how close to the time of the aerial surveys do the calibration data need to be collected? So for the grain size, that's derived from the imagery itself, so that could be done at any time. From the depth side of things, that needs to be pretty close, ideally on the same day of the survey. So you would go to a point on the river and collect that depth calibration data on the day or very close to it. Essentially, you know, once conditions within the river change, that calibration data is not going to be valid. However, if we're moving on and deriving that photogrammetrically now, then that calibration data can be collected at any point. And then just to confirm, the cost you gave of 200 to 300 a kilometre inclusive of all costs for aerial surveys. Yes, yeah, and there's some big caveats around there, because, you know, there's so many variables with these things that you really do have to cost it up on a case by case basis. But yeah, that kind of gives an idea. The FIS is nearly 8+ years old. Are there any updates or few developments in this area of science? So again, yeah, as I was saying, trying to replace the depth aspect of it, so we don't need to go out and send someone to calibrate on the day of survey. That's something that's been developed, and, you know, as the the main area of development is just with the better and better camera systems that are getting better and better imagery. So we're able to cover much larger areas much more quickly and for much more detail. So the resolution is going up, so the detail is going up, and kind of the input data is getting better all the time. And I think that's the last question. So we're almost out of time. So unless there's anything else, that's I'll probably stop there. Thank you very much for everyone's time and for listening and for asking so many questions, and really good questions. So thank you for your interest there.
Thank you, David. Yeah, and thank you everybody for joining us. We'll send a feedback survey out shortly this afternoon, and also we'll send the recorded webinar to you all. So yeah, I think that brings the webinar to a close. We've had a lovely comment from Flora. Thank you, David. Very interesting and inspiring. So yeah, well,
thank you very much.
Thanks everyone for joining. Bye bye.
See you everyone. Bye.